Hello, and welcome to Space Science Before Sleep. If a galaxy could breathe, where would we notice it first? In the slow widening of its arms, or in the quiet pull of its hidden center? Maybe it has been a long day for you. The kind that leaves a little weight behind your eyes, or the kind that keeps your thoughts moving, even after the room has gone still. And if your mind feels busy, you do not need to fight it tonight. Can simply let it loosen one gentle moment at a time. You have got nothing to do but rest. Let your breathing slow down just a little. And as you exhale, allow your shoulders to soften, as if they have remembered they do not need to hold the day anymore. And if it helps, imagine your body becoming lighter, not floating away, just settling more comfortably into the place where you are supported and safe. Tonight we are drifting through the Milky Way, not as a rush, not as a race, but as a slow bedtime journey through a galaxy that has been turning for far longer than any human clock. And if this helps you unwind, consider liking and subscribing. For this whole story, I will keep one simple promise. We will move gently, fact by fact, and let wonder arrive softly, without urgency, without worry, as though we are watching distant starlight ripple across calm water. One calm orbit at a time. Now let us begin. To understand the Milky Way in a way that feels soothing, it helps to borrow a sense of time from the galaxy itself, a time scale so large that it makes the rest of life feel quiet and simple. And that is the idea of a galactic year. A galactic year is not the kind of year we mark on calendars. It is not the turning of seasons on a single world. It is the long, steady time it takes our sun, with all its planets, to make one complete loop around the center of the Milky Way. And when you picture that, you can imagine our solar system as a small lantern on a wide path circling a distant hearth of starlight and gravity. Scientists estimate this orbit takes a few 100 million years, and it is difficult to truly feel a number like that in the body. So instead, let it become a rhythm, a slow heartbeat for the whole galaxy, a calm clock made of motion where each tick is not a second, but a long sweep through space. In that sense, you are always traveling through a year that is far larger than the idea of a year. You are resting inside a journey that began long before humans learned to name the stars, and will continue long after the last streetlight turns off on Earth. And yet, even with all that time there is nothing hurried about it. The Milky Way does not sprint, it turns. This gentle turning is one of the most comforting truths in astronomy. Almost everything in the universe is moving, but much of it moves with patience. And the Milky Way is full of patient motion stars, orbiting gas-drifting clusters slowly, reshaping all of it, happening on timescales that feel like calm silence when compared to the quick noise of daily life. Our sun does not orbit alone. It is one of hundreds of billions of stars, each on its own path, some on nearly circular tracks, some on more stretched loops, and some with histories that have left them on stranger routes. But most of them share the same broad sense of rotation, like leaves carried along in the same wide river. If you were able to step outside the galaxy and watch from far away, the Milky Way would not look like a still photograph. It would look like a slow-turning record, a spiral disk rotating around a crowded central region, and the sun, far from the center, would be one quiet point, making its way along the broad, outer lanes. When people talk about the galaxy, they often speak as if it has a clear edge, and as if everything within it is neatly arranged. But a real galaxy is softer than that. Its borders fade, its outer regions grow thin, its halo extends beyond the sight, bright disk, and its paths overlap and mingle. And this softness is part of what makes it a good bedtime story. It is not a machine. It is a living pattern shaped by gravity, time, and the slow gathering of matter. While our solar system travels, the galaxy itself is also changing, not dramatically in a single night, but gradually, like a landscape changing through slow weather. Stars are born and die, clouds collapse and disperse, and the spiral arms keep their graceful shape even as the material within them moves. Tuon. It can be tempting to imagine that the spiral arms are like fixed limbs, solid structures made of the same stars forever. But they are more like patterns in motion, the way a gentle wave keeps its form, while the water beneath it flows. And as prophet, we move deeper into the story. These arms will become our next calm landmark, long curved lanes of starlight that guide the eye and hold the imagination. For now, though, stay with the galactic year, because it teaches the first, most soothing lesson of the Milky Way, that a galaxy can be vast and still feel steady, that something unimaginably large can keep time without tension. The galactic year also gives you a quiet perspective on what it means to be here tonight on a small planet in a warm room, listening to a story. Because when you zoom out far enough, your whole life fits into a tiny fraction of a single orbit. And that is not meant to diminish you. It is meant to relax you, to remind you that you do not have to carry the universe you are already being carried. Our planet, our moon, the planets beyond the comets at the edge, all of it goes along with the sun, like a calm caravan. And together, we glide through the galaxy, passing through different neighborhoods of gas and dust, over long stretches of time, sometimes nearer to spiral features, sometimes farther from them, always moving, always supported by the gentle rules of gravity. And gravity in this context is not an alarm. It is the soft rule that keeps things from flying apart. It is the quiet agreement between mass and motion, and it will return again and again in our journey, as the unseen structure behind what we can see. Even our idea of where the sun is in the galaxy is part of this calm motion we live in. The disk not near the very center, not at the farthest edge, but in an outer region that still contains plenty of stars. And as our sun moves, it weaves its way around the center with a speed that sounds large when you put it in everyday units, yet feels smooth, because there is no friction in the dark, no resistance, only orbit. If your mind likes images, you can picture the Milky Way as a quiet clock face, not with numbers, but with starlight, and the sun as a slow-moving hand sweeping around once per galactic year. And if you prefer something softer, you can picture it as a calm pathway through a nighttime garden, a long, circular stroll that takes ages, with the center as a distant fountain you can hear but not see. As your breathing settles, you might notice how different this scale of time feels. It is so slow. It does not press on you. It does not demand anything. It simply exists. And sometimes that is exactly what the mind needs before sleep, a thought that is large enough to hold all other thoughts and gentle enough to let them drift. In the Milky Way, the galactic year is not just a measurement. It is a way of describing the galaxy as a stable home, a place where motion is normal, where change is gradual, where even dramatic events like the merging of galaxies unfold like a slow blending rather than a sudden crash. Later we will talk about those long memories, about smaller galaxies that have drifted close and been gently taken apart, leaving streams of stars like ribbons. And we will talk about Andromeda, far away, and slowly approaching a neighbor on a patient path. But all of that rests on this first calm principle that the Milky Way has time, and so do you. You do not need to solve the day tonight. You do not need to race tomorrow into existence. You can rest inside the knowledge that the universe itself is not hurried, even as it moves, and that your quiet room is part of a much larger quiet motion, one calm orbit at a time. In the next part, we will let the galactic year guide us outward into the spiral arms, and we will watch how patterns can flow and drift without breaking like currents in a slow cosmic sea. As you continue to rest, let the idea of the galactic year stay close, not as a statistic, but as a gentle tempo, the kind that makes the mind feel less crowded, because there is something calming about realizing that the sky has its own slow schedule, and it keeps it without effort. Our sun, with Earth and the other planets traveling alongside, is on a long path around the Milky Way's center, and although we often speak of it as a single circle, the reality is softer, more like a roaming lane within a wide disk, where countless stars share similar routes, each orbit shaped by the both total gravity of the galaxy, visible and invisible together. When scientists talk about this orbit, they use careful measurements, the motions of stars, the distribution of gas, the way objects move at different distances from the center. And the quiet truth behind all of it is that our solar system is part of a larger, steady flow, the way a single leaf becomes part of a river without needing to understand the whole watershed. And for bedtime, that is a comforting thought. You are not standing still, but you are also not falling. You are gliding, held in a pattern that has endured for billions of years. Sometimes people imagine that if everything is moving, we should feel it. But in orbit, motion is smooth. There is no sudden push, no jolt, and so the galaxy's movement can be enormous in scale, while remaining gentle in experience. And that is why you can lie quietly in bed while still traveling through space. If you enjoy visualizing it, you can picture the Milky Way as a wide, thin disk of light, a soft spiral seen from above, and our Sun as a warm dot in one of the outer regions, circling at a comfortable distance from the bustling center. And as it moves, it carries a small bubble of planetary orbits with it like a calm lantern moving through a dim landscape. This is where the galactic year becomes more than a measurement. It becomes a way to frame a story. Because once you accept that the galaxy keeps time with orbit, you can start to notice that the galaxy also keeps patterns, and those patterns are what we usually call spiral arms. But before we reach the arms fully, it helps to notice a subtle detail. The Sun's path is not simply a flat line in a perfect plane. The Milky Way's disk has thickness. The Sun sits slightly above or below the midplane, depending on how you define it. And over time, it gently bobs, moving up and down through the disk in a slow oscillation, like a boat rising and falling on a calm swell. This motion is not dramatic. It is part of the natural dance of stars in a galaxy. And it adds another layer to the idea that the Milky Way is not a rigid structure, but a living flow, a system where countless orbits overlap where gravity is, the quiet rule, and where the passage of time is written in curves. The galactic year is also a reminder that the Milky Way's center is not just a point on a map. It is a real region with a strong influence, a place where the density of stars rises, where the gravitational pull deepens, and where the inner galaxy moves to its own rhythm, faster, busier, yet still governed by the same calm laws. Out where we live, the orbit is wide, and wide orbits feel unhurried because they cover so much distance. And this is another soothing truth. The farther you are from the center, the longer and gentler the loop tends to feel, and our Sun's journey reflects that. If you think about human years for a moment, they are made of repeating cycles. We can feel seasons, days, nights, the turning of the Earth, the orbit around the Sun. And these cycles help our minds organize time. They create a sense of before and after, beginning and ending. A galactic year does something similar, but at a scale that dissolves the sharpness of daily life. It makes the idea of urgency feel smaller. It turns worries into tiny ripples on a vast sea. And it invites the mind into a bigger room, where thoughts can spread out and become softer. There is also a quiet beauty in knowing that our Sun has been making these orbits for a long time, not quite the same path each time, because the galaxy evolves, but still a recognizable journey, and each orbit carries the solar system through different galactic environments, sometimes through regions, with slightly different densities of gas. Sometimes near the edges of spiral structure, sometimes in quieter inter-arm space. Over immense spans of time, these passages can influence how much material passes through our neighborhood, how often clouds drift nearby, how often distant supernovae might be seen from afar. But tonight we do not need to focus on extremes. can let it remain a gentle concept that the galaxy is a landscape we travel through slowly, and just as the sun moves, so do the spiral patterns. And that is where we are headed next. Because the spiral arms are not simply decorations. They are part of how the galaxy organizes its gas, its dust, its star formation, and even its sense of motion. For a moment, imagine standing above a calm ocean and watching long bands of currents, not waves that break, but flows that guide, drifting pieces of kelp forming lines and swirls. And then imagine that those currents were made not of water, but of gas and stars stretched across tens of thousands of light years. And you begin to have a bedtime-friendly image for spiral arms. When you look at pictures of spiral galaxies, the arms appear as bright, curved lanes. And in many cases, that brightness comes from a combination of things. Clouds of gas where new stars are born, clusters of young luminous stars that shine strongly, and dust lanes that trace structure by blocking and reddening light, and altogether they create the familiar spiral look. But beneath that appearance, the arms behave like patterns that move through the disk, and stars move through them, meaning the stars you see in an arm today will not necessarily stay there forever, the same way a car can move through a traffic wave on a highway, experiencing the pattern without being the pattern. This is one of the most calming ways to think about the Milky Way. The galaxy is full of traveling things and traveling patterns, and both can coexist. And when you bring that idea back to your own mind, it can feel like permission. Thoughts can pass through without needing to become permanent. If you are still awake enough to enjoy one more gentle cue, take another slow breath and let your jaw relax. Let your tongue rest comfortably and allow the space behind your eyes to soften, as if the day is gently dimming in your inner sky. In the next part, we will drift into the spiral arms more fully and explore them as flowing currents, as drifting patterns, and as the soft architecture that helps the Milky Way look the way it does, all while the galactic year continues. Quietly in the background, steady and calm. Tonight, as we move a little farther, let the Milky Way feel less like a picture and more like a slow piece of music where the galactic year is the long, steady beat and the spiral arms are the melody that rises and falls across the disk. When you imagine a spiral arm, it is easy to picture it as a solid ribbon of stars, a permanent lane that stays fixed while everything else circles around. But the Milky Way is gentler and more subtle than that, because the arms are not stiff structures, they are patterns, and patterns can travel through a system without needing to hold on to the same material. A calm way to think of this is to imagine a wide field of grass moving in the wind. The wave you see rolling across the surface is real. It has shape and speed, but the individual blades of grass do not travel with the wave for long. They tilt, they sway, and then they rise again as the pattern passes. And in a similar way, much of the spiral structure can be described as a density wave, a moving region where gas and stars are slightly more crowded than their surroundings. This does not mean every detail is settled. Galaxies are complex, and the Milky Way has its own quirks. But as a bedtime story, the essential idea is simple. The spiral arms are like gentle traffic waves in the galaxy's disk places. Material tends to gather, compress, and then drift onward. Gas, in particular, is sensitive to these patterns because gas can compress more easily than stars can. And when gas drifts into a denser region, it can bunch together, cool, and begin the long process of forming new stars, and those newborn stars often shine bright and blue, at least for a while, which makes the arms look luminous. So when we see spiral arms glowing, we are often seeing places where star formation has been active relatively recently, and where clouds of gas and dust are arranged in long arcs. And this is why spiral arms can feel like rivers of light, because they are tied to flow, to drift, to continuous motion. Now, the Milky Way is a barred spiral galaxy, which means it has a central bar, a long, slightly stretched region of stars through the middle, and that bar interacts with the spiral pattern, helping to shape how the arms connect and how material circulates from the outer regions toward the inner ones. And we will return to the bar later when we drift toward the core. But it is worth keeping in mind now, because the spiral pattern is part of a larger choreography. For the moment, let us stay with the arms as currents. If you could float above the Milky Way, you might see the disk as a soft haze of stars, dust, and gas. And within that haze, the arms would appear as gentle, sweeping arcs. And within those arcs, you would find the places where gas clouds gather, where clusters of young stars shine, and where dust lanes create darker threads like ink lines on a faintly glowing page. But you would also notice something else. The arms do not behave like rigid spokes on a wheel. They wind, they branch, they feather, and they blur. And they do this because a galaxy is not a simple rotating object. Different parts of the disk can rotate at different rates, and the arms are shaped by the way gravity organizes a rotating disk over time. This is one reason spiral arms feel so natural to the mind. They are patterns that emerge from simple rules: rotation, gravity, and the presence of gas. And yet they appear almost artistic, like a calm painting made by physics. When you place our sun into this picture, you can imagine it traveling through the disk, sometimes nearer to the brighter spiral features, sometimes in quieter interarm regions. And over a galactic year, it traces a long loop that passes through different textures of the galaxy. And this can feel like a soothing metaphor for life, passing through busy seasons and calmer seasons, but always continuing. The spiral arms are also not all the same. Some are more prominent, some are more diffuse. And because we live inside the disk, our view is complicated. We see the arms not as neat curves, but as directions in the sky where we look through more material, more stars, more dust, and we infer the structure by mapping gas, by tracking star-forming regions, and by studying the motions of objects across the galaxy. It is a quiet triumph of astronomy that we can piece together this structure from within, like learning the shape of a forest while standing among the trees. And even though the details are refined with each new survey, the overall picture remains a spiral disk, a bar, a bulge, a halo, all turning together. As we think about the arms as flows, it is helpful to remember that stars do not move like boats on an ocean current. They move mostly under gravity on their own orbits, but the pattern of density can guide where gas collects, and gas is the ingredient that allows the arms to light up with new star birth. And this is why the arms often feel alive, because they are places where new light is being made. And yet even here we can keep it calm, because star formation in a galaxy is not a sudden blaze. It is a slow process. Clouds collapsing over long times, stars forming in clusters, and those clusters gradually dispersing, and the arm pattern continuing steady and patient. If your mind likes to settle on an image, imagine the spiral arms as wide, slow streams of starlight, with darker dust lanes like soft shadows within them. And imagine our solar system as a small, quiet boat moving along a much larger circular route, occasionally passing near these streams, occasionally moving between them, always held by the gentle gravity of the galaxy. Now, as we drift a little farther into this idea, we can also begin to notice that the Milky Way does not lie perfectly flat. And this leads us toward one of our signature segments. Later, the disk warp, a subtle bending in the outer regions, like a silk sheet that has been lifted slightly at the edges. And the arms too can participate in this three-dimensional shape. But before we go there, let us linger for a moment on the feeling of flow, because it is the key to understanding spiral arms without tension. Spiral arms are not traps. They are not walls. They are gentle patterns and stars, and gas drift through them. And the galaxy continues its long rotation, and the arms continue to appear. And in this way, the Milky Way is like a calm system of currents, always moving, always reshaping, never needing to hurry. If you notice your thoughts becoming active again, you can let them be like stars in the disk, each one on its own path, And you can let the spiral arm be the pattern that holds them, not by force, but by gentle structure. And then you can let the thoughts drift on the way stars drift through the party. Arms. In the next part, we will stay with the arms a little longer and explore why they look bright, how dust shapes what we see, and how the galaxy can carry both young light and ancient stars within the same sweeping curves. And then soon after, we will slip into our first signature segment, the soft bending of the Milky Way's disk like a ripple in silk. For a moment, stay with the spiral arms as gentle currents, because once you begin to see them that way, the Milky Way becomes easier to imagine from the inside, and it also becomes easier to rest your mind inside the image, the way you might rest your gaze on slow-moving clouds. When we say spiral arms, we are describing a pattern that has both light and shadow woven through it, and the light and shadow come from different ingredients, some visible, some only inferred, and together they shape the calm face of our galaxy. One of the simplest reasons spiral arms look bright is that they tend to host many young stars, and young stars often shine strongly, especially in blue and white light, but they do not stay young for long. By cosmic standards, many of the most luminous ones burn quickly and fade or end their lives on much shorter timescales than calmer stars, like the sun. And so the brightest glow in spiral arms can be a kind of gentle signpost, showing where the galaxy has recently been busy making new stars. But stars are only one part of the story. Between the stars, the Milky Way contains gas, mostly hydrogen, and also dust, tiny grains made of elements like carbon and silicates. And these dust grains are small, more like smoke particles than like sand, and yet they have a powerful effect on what we see because dust can block and scatter visible light. This is why when we look toward certain directions in the Milky Way, we see dark lanes, not because there are no stars there, but because dust is absorbing or scattering their light before it reaches our eyes. And those lanes often trace the same spiral structure, giving the arms a textured, layered appearance, bright regions beside soft darkness, like ripples on a deep river at night. Dust also helps create the conditions for star formation, because dust can help clouds cool by allowing energy to be radiated away. And cooling matters because gas that cools can collapse more easily under gravity. And collapse, beginning of star birth. So the arms are not just bright because they contain young stars. They are also bright because they contain the raw materials that make young stars, gas clouds, dust lanes, and complex chemistry and the galaxy's rotation and gravity gently herd these ingredients into long, curved regions where they can gather. It helps to imagine that the Milky Way's disk is not uniform. It has subtle variations, regions that are slightly denser, slightly richer in gas, slightly more likely to host the slow process of cloud collapse. And as the galaxy turns, these regions can persist as patterns guiding the flow of matter like a wide, slow current line. At the same time, the stars themselves do not belong to an arm forever. A star is born in a cloud, often within or near an arm, but as it continues on its orbit, it can drift away from the region where it was born, and over long spans of time, it may pass into inter-arm space, and later pass near another spiral feature. And this drifting is part of why spiral arms can remain patterns rather than fixed collections. So in a single spiral arm, you can find a mixture of ages, young clusters that sparkle briefly, older stars that have been circling quietly for billions of years, and gas that is always moving, always reshaping. And this mixture gives the arms a comforting sense of continuity, the new and the old sharing the same soft curves. Interarm space, the regions between the spiral arms, is not empty. It still contains stars and gas, but it tends to have less concentrated star formation and fewer thick dust lanes. And because of that, it can feel calmer in a visual sense, more evenly scattered, and many galaxies show these quieter, lanes between the bright arcs, like pauses between phrases in a slow song. If you like gentle metaphors, the arms are like the brighter passages of the melody, and the interarm regions are like the soft rests that make the melody feel spacious, and both are part of the same piece of music. Because we live inside the Milky Way's disk, we do not see the arms as a neat spiral from above. We see them as layered directions in the sky, and our view is shaped by the way we look through the disk, sometimes looking along an arm, which means looking through a long corridor of stars and gas, and sometimes looking across the disk into regions where dust blocks our view. And in that sense, mapping the Milky Way is a careful act of listening and inference. Astronomers use many kinds of light to do this, because dust blocks visible light, but lets other wavelengths pass more easily, and gas has its own signals, and by combining maps of different wavelengths, scientists can trace where the spiral structure is likely strongest, where star-forming regions cluster, and where the galaxy's material is flowing. Even if you do not remember the technical methods, the calm fact remains: the Milky Way is a spiral pattern, seen from within, pieced together by patient observation, and it is a gentle reminder that not all understanding comes from stepping outside. Sometimes, understanding is what you build slowly while living inside the thing you are trying to know. As we drift through this picture, it is also worth noticing that spiral arms are not perfectly symmetrical, and they can change over time. And the Milky Way may have segments and spurs, smaller branches, that reach between main arms, and these features are part of how a real galaxy looks when you observe it closely, not as a perfect diagram, but as a living structure. And all of this is still happening inside the slower frame of the galactic year. The arms flow, the gas drifts, the stars orbit, and our solar system continues its long loop. And if you let that be the background rhythm, it can feel deeply calming, because it places everything into a scale where nothing is urgent. If you feel your mind starting to wander, you can let it wander gently, the way a small cloud drifts across a larger sky, and then bring it back to one simple image: the Milky Way as a slow-turning disk with spiral arms like soft currents of light. There is another detail that fits beautifully into this calm picture, and it prepares us for the next step in our journey. The Milky Way is not a perfectly flat record. It has subtle thickness and subtle bending, and in the outer regions, disk appears to warp, as if the far edges lift and dip. This warp is not dramatic, and it is not something you would notice in a casual glance, but it has been traced through maps of hydrogen gas and the motions of matter in the disk, and it suggests that even on vast scales, the galaxy can have a gentle ripple. And now we are approaching our first signature segment, where we will treat that warp as a bedtime image, a silk sheet in slow motion, bending softly under the influence of gravity and interaction. And we will keep it fact, safe and calm, letting the scientific idea become a gentle scene you can rest inside. For now, let yourself sit in the quiet contrast of arms and inter-arm space, bright arcs and softer lanes, dust that shades and shapes, gas that gathers and releases, stars that are born and then drift onward and through it all, galaxies unhurried turning, keeping time in the dark one calm orbit. At a time, a little farther now, and we can let the Milky Way become not only a spiral, but a shape with depth, because real galaxies are not perfectly flat, and the more carefully we listen to the evidence, the more we find gentle bends, soft thickness, and slow three-dimensional motion that makes the disk feel like fabric rather than metal. From where we live inside the disk, this can be hard to picture, because our view is always through layers, through dust, through crowded starfields, through glowing gas. But when astronomers map the galaxy using signals that travel through dust more easily, especially the broad distribution of hydrogen gas, a quiet pattern appears in the outer regions. The disk does not remain perfectly level. It seems to lift on one side and dip on another, forming what we call a warp. Warps are not unusual in spiral galaxies, and that is comforting in its own way. It means our galaxy is not broken or strange. It is simply alive in the way large systems often are, responding slowly to gravity, to the gentle pull of companions, and to the long memory of past interactions, all without needing to make a dramatic show. When you imagine a warp, it helps not to think of a sharp crease, but of a slow ripple, like the way a wide lake can have a long swell that rises and falls over great distances, or the way a sheet can bend when the air moves beneath it. Bend is real, but it is smooth, and it does not tear. In the Milky Way, the warp is mostly traced in the outer disk, where the galaxy becomes thinner and more delicate, and where the gas extends farther out than many of the brighter stars. And this is why hydrogen maps are especially helpful. Reveal structure in places where starlight is faint. The causes are still studied, and there is room for more learning, but evidence suggests that the warp may be shaped by the galaxy's environment, the gravity of nearby companions, the long influence of the dark matter halo, and the fact that galaxies grow by accreting material over time, sometimes from directions that are not perfectly aligned with the existing disk. And when new material settles in, it can encourage a gentle twist or bend. Signature segmentor. Imagine the Milky Way's outer disk as a vast silk sheet spread across the dark, so wide that a single fold would be measured in thousands of light years, and yet so light in its outer reaches that it can respond to a quiet tug. When astronomers map hydrogen gas across the sky, they see that the far edges of the disk do not sit in a single flat plane. Instead, the evidence suggests a slow rise in one direction and a slow dip in another, like silk lifted by a breeze that you cannot see. This warp does not mean the galaxy is unstable. It is more like a relaxed posture, a natural shape that forms when gravity, rotation, and the surrounding environment negotiate over long time. Scientists are still learning how much comes from past encounters, how much from the pull of companions, and how much from the way fresh gas settles into the disk. In a calm way, the warp becomes a reminder that even immense structures can be flexible, and that the universe often prefers curves over corners. As we come back from that image, keep the feeling of softness. The spiral arms we have been drifting through do not float above the warp. They are part of the disk, and so the arms and the warp belong to the same fabric. And that means the arms are not just curves on a flat page. They can be part of a discrete, gently bending surface. And that adds a quiet beauty to the idea of a galactic map. It is not only a spiral, it is a spiral that lives in 3 dimensions, like a ribbon that can lift and dip as it wraps around a distant center. This is also a good moment to notice how the warp fits into our larger journey, because we are still moving in the order of the galaxy's calm story. First, the galactic year, as a slow clock, then spiral arms as flowing patterns, and now, the port. Sense that the disk itself is a soft structure, and soon we will move into the quiet framework behind all of it. Dark matter, the invisible scaffold that helps explain how galaxies hold together and how their motions make sense. But before we step into that unseen structure, it is worth lingering in the arms and the disk for one more gentle breath, because the arms, the dust lanes, the star-forming regions, and the warp, all of these are different expressions of the proper same underlying truth. The Milky Way is a dynamic system, yet its dynamics are slow, and its changes are patient. If you picture our sun moving through this environment, it is like a small, warm point, traveling across a very large, very gentle surface, circling the center in a long orbit, passing through regions of different density, and doing so without comfort, drama, just steady motion. And if your mind wants to attach this to a feeling, you can let it become a sense of reassurance, because in a universe that can feel overwhelming when described in sharp terms, the real galaxy is full of slow gradients, soft transitions, and long-time scales that do not press on you. In the next part, we will begin to speak more clearly about what cannot be seen directly, the dark matter halo, and how scientists infer its presence by watching how the galaxy rotates and how stars and gas behave. And we will treat it as quiet structure, a gentle scaffolding that supports the visible spiral without ever needing to shine. For now, let the image of the silk sheet remain the Milky Way's disk, slightly bent at the edges, still turning, still flowing, still holding its spiral pattern, and you resting within it, carried by the same calm physics, one calm orbit at a star. Time. As we drift onward, we can let the bright spiral arms soften into the background for a moment, because the Milky Way is not held together by light alone, and some of its most important structure does not glow at all. When astronomers first began to measure how galaxies rotate, they expected a simple pattern. The closer you are to the center, the faster you orbit, and the farther out you go, the slower the orbit should become. In the same way that outer planets in a solar system move more slowly than inner ones. In a galaxy, though, the story does not follow that simple expectation. When we watch stars and gas in the outer parts of spiral galaxies, including our own, the evidence suggests they are moving faster than the visible matter alone would allow. If only the stars, dust and gas we can see were providing the gravity, the outer regions should not be able to keep up the speeds. We observe they would drift differently, and the galaxy would not hold the same stable shape over long time. So scientists began to consider a calm and quietly powerful conclusion. There must be additional mass. We do not see mass that does not shine, like stars, mass that does not glow like gas, and mass that does not block light like dust. This is what we call dark matter. It is important to say this gently, because the word dark can sound like a mood, but here it is simply descriptive. Dark matter does not appear to interact with light the way ordinary matter does. It does not emit light, it does not reflect light, and it does not absorb light in the ways our telescopes easily detect. And yet, it reveals itself through gravity, through the way galaxies rotate, through the way clusters of galaxies hold together, and through the way light bends as it passes near large concentrations of mass. So dark matter becomes in this bedtime story an invisible scaffold, the quiet structure that supports the visible spiral. In the Milky Way, dark matter is thought to form a broad halo surrounding the disk, extending far beyond the bright region where most of the stars reside. And while we cannot take a photograph of this halo, we can infer its presence by watching how objects move, especially in the outer galaxy, and by studying the overall gravitational field that seems necessary to produce the motions we measure. If you are resting with this idea, it can help to picture the galaxy as a lantern, bright and detailed in the center, with a soft fading glow outward, and around that lantern, an unseen framework that shapes its motion like a delicate skeleton, made of gravity. The simplest way to understand the evidence is to return to the idea of rotation, because the Milky Way, like other spiral galaxies, has stars and gas orbiting around its center, and the speed of that rotation at different distances tells us how much mass is enclosed within those orbits. If the mass were concentrated only where the light is, the outer orbits should slow down. But many measurements show that rotation remains relatively high, even far from the center. And this suggests a great deal of mass is distributed in a broader, more extended way. This is not a sharp statement of certainty about every detail. Galaxies are complex, and our measurements improve over time. But the overall picture has held for decades. Something unseen is contributing substantial gravity. Dark matter also helps explain another gentle fact. The Milky Way has a halo of stars and globular clusters far beyond the main disk, and many of these objects move in ways that suggest they are orbiting within a deep gravitational well, larger than the visible galaxy, and the halo is the natural place to think of dark matter as dominant, because the density of stars becomes thin, but the gravitational influence remains strong. This brings us to a calm and slightly surprising idea. the Milky Way may be mostly invisible by mass. The stars and gas that make the spiral arms and the glowing disk are the part we can see. But the evidence suggests the total mass of the galaxy, including its dark matter halo, is much larger than the mass of the luminous part alone. And so, the bright spiral may be only the highlighted surface of a much larger structure. This does not need to feel unsettling. It can feel like quiet reassurance because it means the galaxy is supported by something steady and extensive, a broad gravitational presence that helps it remain coherent over cosmic time. You can think of it the way you might think of a tree. The leaves are visible, the trunk is visible, but the roots extend beneath the ground, shaping stability, gathering support, and holding the whole organism in place, even though you cannot see them from a distance. In this metaphor, dark matter is not a mysterious fog to fear. It is a set of roots made of gravity, and the luminous galaxy is the canopy. There is also a second gentle thread here. Dark matter is not only about keeping galaxies together, it also seems to play a role in how structure formed in the first place. Because in the early universe, matter was spread more smoothly. Over time, it gathered into denser regions that would become galaxies and clusters. If dark matter interacts mostly through gravity, it can begin to clump and form scaffolding patterns that ordinary gas can fall into, and then gas can cool and form stars within those gravitational wells. And this is part of why astronomers describe dark matter as a framework it may have helped lay out the broad architecture of the cosmos long before the first stars lit up. So when we talk about spiral arms as flowing currents, it is worth remembering that they flow within a gravitational landscape, and that landscape is shaped by both the visible mass in the disk and the invisible mass in the halo. The disk warp, the spiral patterns, the calm orbit of the sun, all of them occur inside this larger gravitational story. If your mind wants a simple bedtime image, imagine the Milky Way as a bright spiral drawn on a transparent sheet, and behind that sheet, a faint unseen shape that supports it. And even though you cannot see that shape, the spiral keeps its form, because it rests within that gentle structure. It is also fair to say softly that we are still learning what dark matter is made of. Astronomers and physicists have proposed several possibilities, and experiments continue to search for clues. But for our journey tonight, we do not need to chase the details too sharply, because the key fact is the role it plays. Whatever its nature, it behaves like mass. It exerts gravity, and it shapes the motions of galaxies. Sometimes, when we speak about something unseen, the mind can start to reach for dramatic images, but you can let it stay calm, because the effect of dark matter on daily life is gentle and indirect. It is part of the background structure, the universe like the quiet curvature of Earth that shapes oceans and wind without needing to announce itself. And in a way, it matches the mood of bedtime. The most important supports in life are often the ones you do not think about while you rest: the mattress beneath you, the floor beneath the bed, the steady pull of gravity itself, all invisible in their function but always present. Dark matter is like that, a quiet support in the cosmic sense. In the next part, we will step into our second signature segment, and we will spend time with the dark matter halo in a more poetic way, letting it become a gentle architecture you can imagine, while staying close to what the evidence suggests. And from there, we will begin to turn toward the Milky Way's long memory, the collisions and mergers that have shaped it, leaving stellar streams like faint handwriting in the outer sky. For now, rest with this simple thought: the bright Milky Way you imagine is real, but it is held by more than what you can see, and the galaxy continues its slow turning within an unseen scaffold of gravity. Steady, patient and quiet, one calm orbit at a time. For a moment, let us stay in the realm of the unseen, because sometimes the quietest ideas are the ones that hold the most weight. And dark matter, whatever its true nature turns out to be, is one of the calm foundations of the Milky Way. When you look up at the night sky, you see stars scattered like salt across velvet, And if you imagine the Milky Way as a soft band, you can almost feel its shape. But the evidence suggests that what you see is only the bright inner portion of something far larger, like a lantern inside a wide, invisible globe. Astronomers describe this larger globe as the dark matter halo, a vast region surrounding the disk and bulge extending far beyond, where the starlight thins into darkness. And it is not a hard shell. It is more like a gentle gradient, thicker toward the center and more diffuse outward, a broad distribution of mass that changes slowly with distance. If you picture it as a halo, let it be a halo of gravity rather than a halo of glow. We infer it in several ways: by studying how stars and gas move, by watching the orbits of globular clusters and satellite galaxies, and by noticing that without an extended mass distribution, the galaxy's observed motions do not fit as smoothly. And when we compare many galaxies, we find similar patterns suggesting that this invisible component is common, not unique to the Milky Way. Now, to keep this bedtime friendly, we can let the technical details remain soft and focus on the feeling of structure. The Milky Way has spiral arms that look like flowing currents. It has a disk that can warp like fabric, and it has a calm, long orbit for the Sun. And all of those features exist inside a gravitational environment that is larger than the visible disk. And this environment is what gives the galaxy a sense of being held together, not tightly, but steadily. Signature segment 2. Imagine stepping back from the Milky Way until the bright spiral becomes a small glowing shell, and then noticing that around it there is a much larger presence, not seen in light, but felt in the way everything moves. Scientists infer that our galaxy is embedded in a dark matter halo, a broad, extended structure that may reach far beyond the visible stars. The evidence comes from rotation curves and the motions of objects in the outskirts, where the pull of gravity seems stronger than starlight alone would suggest. If you want a gentle image, think of the bright galaxy as a boat floating on a deep ocean of gravity. The ocean itself, unseen, but shaping the boat's path with quiet steadiness. We are still learning what dark matter truly is, but its role is clearer. It helps explain how galaxies remain bound and how large-scale patterns formed over time. In that sense, the halo is like a calm architecture, not a wall, not a curtain, but an invisible framework that lets the luminous spiral keep its graceful shape. As we return from that image, it is worth noticing how this unseen framework connects to the next part of our story, because a galaxy's history is written in motion, and the motion we observe today is shaped not only by the stars we can see, but by the total gravity of the system, visible and invisible, together. This means that when smaller galaxies drift near the Milky Way, their paths are guided by the Milky Way's full gravitational landscape, including its dark matter halo. And over time, these encounters can leave traces not as loud events, but as revisitor. Long, delicate signatures, streams of stars that arc around the galaxy like faint ribbons. This is how we begin to move into the next stage of the journey, collisions and mergers as memory. The word collision can sound harsh, but in astronomy, many collisions are more like slow dances, because the distances between stars are vast. So when galaxies merge, the stars usually pass by one another without direct impact. What changes? The overall structure, the orbits, the distribution of gas, and the way gravity rearranges the combined system over time. In a galaxy like the Milky Way, this process has been happening for billions of years, not as a constant storm, but as a gradual growth. Smaller galaxies and star clusters drawn in, stretched and mixed into the larger halo. And what remains? The quiet footprints of that history. One way to see this is through stellar streams. A stellar stream is a long, thin trail of stars that once belonged to a smaller system, perhaps a dwarf galaxy, or a globular cluster that has been pulled apart by tidal forces, the same kind of gravitational stretching that raises tides in oceans, but on a far larger scale. As the smaller system orbits the Milky Way, gravity tugs more strongly on the side, closer to the center, and less strongly on the far side. And over time, this difference can stretch the system, pulling stars out into extended arcs. These arcs can wrap around the galaxy, sometimes forming long loops, sometimes overlapping, like layered handwriting, and astronomers map them by surveying large numbers of stars and looking for patterns in their positions and motions. Because streams are not always obvious. In a simple photograph, they can be subtle like faint smoke in a dark room. The existence of streams is one of the most peaceful kinds of evidence in astronomy, because it shows that the galaxy keeps a memory, not in a book, but in the arrangement of stars. The past remains present as geometry. And this memory is not only about what was absorbed, it is also about how the Milky Way grew. Because a spiral galaxy is not necessarily born as a finished object, it becomes itself over time, gathering mass, forming stars, developing a disk, interacting with companions, and settling into the structure we see now. The dark matter halo again provides the stage for this growth, and the spiral arms provide the flowing surface, and the streams are like old footprints, preserved in the quieter outskirts. In the parts ahead, we will meet one of the Milky Way's most important ongoing interactions, the Sagittarius dwarf galaxy, a smaller companion that has been looping around the Milky Way and leaving streams in its wake. And we will also gently look outward toward Andromeda, a larger neighbor whose far outer regions overlap in the broadest sense, and whose future merger with the Milky Way is a long story already in motion. But before we get there, allow yourself to rest in the simple picture of memory, because it is soothing. A galaxy remembers without trying. It keeps traces without holding on to pain. It changes without panic. And over time, it becomes a layered, complex and still stable home. If you like one more relaxation cue, let your breathing remain slow and imagine that each inhale is like drawing in a quiet piece of starlight, and each exhale is like releasing a thought into the dark, where it can drift away like a star, leaving a stream. In the next part, we will step fully into the idea of mergers and history, beginning with the gentle fact that the Milky Way is not alone, that it has grown through encounters, and that one of the clearest signatures of those encounters is the previa, long faint arcs of stellar streams. Tonight we can let the Milky Way become a story of memory, not the kind of memory that clings, but the kind that settles into shape quietly over long time, like ripples that smooth out, yet still leave a faint pattern on the surface. When people hear the phrase galactic collision, the mind can jump to images of impact and chaos. But galaxies are mostly empty space, and the stars inside them are separated by such enormous distances that direct star-to-star collisions are very unlikely even when two galaxies pass through one another. What changes instead is the overall arrangement, the gravity of two great systems, interacting the way their orbits are reshaped, the way gas can be compressed and stirred, and the way smaller companions can be stretched and gradually blended into a larger host. So a merger is often more like a slow blending of two clouds than a crash of two stones. For the Milky Way, this blending has been part of its life for billions of years. Our galaxy is surrounded by smaller companions, dwarf galaxies, and clusters, some still intact, some already in the process of being pulled apart. And over long time, gravity gently draws many of these companions inward, and as they orbit, they can be tidally stripped, their stars teased out into long arcs that wrap around the Milky Way. These arcs are what we call stellar streams, and they are one of the most peaceful ways the universe tells you its history, because they are delicate, faint, and patient. A stellar stream can begin as a small galaxy or a globular cluster moving along its orbit around the Milky Way. As it swings through regions where the Milky Way's gravity changes across the size of the object, the near side feels a slightly stronger pull than the far side, and that difference stretches the companion. Over time, stars begin to drift away. Not all at once, but gradually, like grains of sand slipping from a hand. And because those stars leave along related paths, they form long ribbons, thin structures that can trace the orbit of the original system for great distances. If you picture the Milky Way as a calm ocean of gravity, then a stream is like foam tracing a current, a visible line that reveals the flow beneath. Astronomers find streams by surveying enormous numbers of stars, looking for patterns in position and motion, and sometimes in chemistry too, because stars that form together often share similar chemical signatures, like a family resemblance, carried in their elements. The picture that emerges is softly astonishing. The Milky Way has many streams, and each one is a clue that a smaller system once traveled nearby and was gently unfolded and absorbed. This is why we call mergers memory, because even after the smaller galaxy is no longer recognizable as its own object, the stars it contributed can remain organized for a long time as faint arcs in the halo, slowly mixing, slowly dissolving, but still telling their story. Among these companions, one of the most important is the Sagittarius dwarf galaxy. It is a smaller galaxy that has been interacting with the Milky Way, moving along an orbit that brings it through the Milky Way's outskirts, and in a broad sense through the larger gravitational environment around the disk. Over time, the Sagittarius dwarf has been tidally stripped, and its stars have been drawn out into streams that wrap around the Milky Way, forming a long looping structure. The exact details of its orbit and the full shape of the streams are subjects of ongoing study, refined as surveys become deeper and more precise, but the calm takeaway is stable. Sagittarius has been a contributor to the Milky Way's growth, and its interaction has left a visible trace in the sky's faintest architecture. If you let that sit in your mind, it becomes a gentle thought. Our galaxy is not a single isolated island. It is a gathering place, a place that has grown by welcoming and absorbing smaller companions, not violently, but inevitably through gravity and time. And the streams are not scars, they are signatures, graceful loops that reveal the Milky Way's long history of becoming itself. There is another quiet beauty in this. Streams do not only tell us about the past, they help us understand the present structure too. Because streams are sensitive to the gravitational field, they move through their shapes and motions, can offer clues about the Milky Way's mass distribution, including the dark matter halo. And this brings us back to the unseen scaffold we spoke about before. In a sense, the streams are like a slow-moving ink that traces invisible gravity, allowing scientists to test models of the galaxy's shape and mass. So the Milky Way's memory does double work. It records what was absorbed, and it reveals the hidden structure that did the absorbing. As we continue this calm journey, it helps to remember how the pieces fit together. The galactic year is the slow rhythm of our sun's orbit. The spiral arms are the flowing patterns in the disk. The dark matter halo is the quiet framework supporting the visible galaxy, and the streams are the long, faint handwriting of past mergers written across the halo and outskirts. Now, holding this idea of history, we can begin to lift our gaze outward, because the Milky Way's story is not only about small companions. Far beyond the Sagittarius dwarf and other satellites, there is a larger neighbor that shares our local region of space, the Andromeda galaxy. Andromeda is another large spiral galaxy, similar in broad type to the Milky Way, and it is moving relative to us in a way that suggests the two galaxies are on a long path toward a future interaction. This future is not a sudden event. It unfolds over billions of years. And even now, in the broadest sense, there are hints that the outer regions of large galaxies, their extended halos of gas and dark matter, can overlap in space long before the bright stellar disks meet, simply because halos are vast and extended. So when we say the Milky Way and Andromeda are already touching, it is best to hold that as a very gentle statement about extended outer environments, not a dramatic collision of stars, but a quiet proximity of broad, diffuse regions. The real merger, the blending of the main stellar systems, is far in the future, and it is likely to be more like a slow dance than a crash, with stars mostly passing by one another, while the overall shapes are reshaped by gravity. And in that future, the Milky Way will gain new memory. Streams and shells and new patterns of motion will form, and over long time, the combined system may settle into a different kind of galaxy. And yet even that is just another chapter of the same calm principle. Gravity reshapes large systems. Slowly. There is something restful about these galactic timescales, because they are so far removed from the pace of a human life. A merger takes longer than any civilization has existed. A stream can persist longer than the time between ice ages. And that does not make your life small, it simply means the universe moves on many layers, fast and slow at the same time. And when you rest, you can choose to rest in the slow layer. If you notice your thoughts becoming bright again, you can let them become like stars in a stream, still part of a pattern, but not stuck, drifting gently along their path. And if you want a small, calming image to carry into sleep, imagine a smart, faint arc of stars curving around the galaxy like a soft ribbon, a quiet record of an old encounter, and imagine that ribbon moving so slowly that it feels almost still. In the next part, we will stay with Sagittarius a little longer, looking more closely at how tidal stripping creates streams, and how the Milky Way's outskirts act as a library of past interactions. And then we will drift outward again towards Su, Andromeda, keeping the tone gentle, the facts safe, and the transition smooth, as the galaxy continues its unhurried turning one calm orbit at a time. For a moment, let the word stream feel as gentle as it sounds, because in the Milky Way, streams are not rushing rivers. They are slow, faint ribbons of stars, moving so gradually that their motion is measured in careful surveys and patient analysis, rather than in anything you could watch in real time. When a smaller galaxy approaches a larger one, the encounter is shaped by gravity, and gravity acts across distance with a quiet persistence. The smaller system feels the pull of the Milky Way, and as it orbits, that pull is not perfectly uniform across its whole body. The side closer to the Milky Way's center is tugged a little more strongly than the far side, and over long time that difference becomes a gentle stretching. Astronomers call this a tidal effect, because it is the same kind of principle that raises tides on a planet. Only here it plays out across many thousands of light years. If you imagine the Sagittarius dwarf galaxy in this setting, you can picture it as a smaller cloud of stars and dark matter moving through the Milky Way's larger gravitational landscape. Each time it sweeps through its orbit, it is nudged and reshaped. Stars begin to drift away from the dwarf, not in a single dramatic moment, but gradually, a few here, a few there, released into paths that remain related to the original orbit. Over time, those released stars form long structures that can wrap around the Milky Way like a scarf laid gently over the shoulders of the galaxy. This is the calm heart of tidal stripping. The Milky Way does not need to smash a smaller galaxy to change it. It only needs to hold it, and time does the rest. The smaller system is slowly unbound, its stars becoming part of the larger halo, and its identity fading into a broader structure. What makes this especially soothing to think about is that the evidence of this process can remain visible for a long time. A stream is like handwriting that has not yet been erased. It can persist as a recognizable arc, even as the stars within it continue to drift. And because those stars share a common origin, they often share subtle similarities in motion and chemistry. This is one reason astronomers can identify them by looking for groups of stars moving together in a coordinated way, and by checking whether they carry the same chemical fingerprints, like a soft shared accent in the language of its elements. The Sagittarius dwarf galaxy is one of the best-known contributors to this kind of structure. It has been interacting with the Milky Way for a long time, and the streams associated with it trace a large loop across the sky. The exact map has grown clearer as surveys have improved, and scientists continue to refine the details. But the main idea is steady. Sagittarius has been gradually stretched, by the Milky Way's tides, and the stars it has shed now form part of the Milky Way's extended halo. If you like a gentle image, imagine a comet in very slow motion, not a comet of ice, but a comet of stars. The small body is the remaining dwarf galaxy, and the long tail is the stream, a trail that curves around the Milky Way, revealing the path of the orbit. Unlike a real comet tail, it does not blow in the wind. It follows gravity, and it moves with a patience that makes the mind feel quiet. These streams also help scientists understand the Milky Way's mass distribution. Because streams respond to the shape of the gravitational field, their geometry can be used to test how the galaxy's mass is arranged, including the shape of the dark matter halo. In a calm way, streams are like tracer dye in a slow current. They reveal an unseen structure by the way they bend and wrap. So the Sagittarius story belongs to two themes at once. It is a memory of a past and ongoing encounter, and it is also a tool for understanding the invisible scaffold that holds the galaxy together. While you rest with this, notice how gently the universe keeps its records. It does not store them in words, it stores them in motion. A star does not need to remember where it came from. Its orbit carries the memory in its path. And this is why the outskirts of the Milky Way matter so much. The bright disk, with its spiral arms and glowing clouds, is busy and crowded. The halo is quieter. It is in the quieter places that faint patterns can survive. Streams, shells, and subtle groupings of stars can persist there because they are not constantly stirred by the dense traffic of the inner disk. In a sense, the halo is a library where the pages are written in starlight and the ink is gravity. Now we can gently widen our view again, because the Milky Way is not only shaped by smaller companions, it also shares a neighborhood with another large spiral galaxy, Andromeda. Andromeda is far away by everyday standards, yet close by cosmic standards, a familiar companion in the local group. Its presence matters not because it is about to arrive, but because its path, relative to the Milky Way, tells a long story that is already unfolding. Evidence suggests that Andromeda and the Milky Way are moving toward one another overall, guided by their mutual gravity and the gravity of the local group environment. The timescale for a major merger is often described as billions of years. That is not a date you need to hold tightly in your mind tonight. It is enough to let it feel like deep future, a chapter so far ahead that it can only be approached as a soft idea. But there is a gentle detail that fits our earlier theme about halos. Large galaxies do not end where their bright disks end. They are surrounded by extended regions of gas and dark matter, and those regions can reach out far into space. So when people say the Milky Way and Andromeda are already touching it, it's best to imagine it as an overlap of broad, diffuse, outer environments, not a meeting of bright star fields. It is a quiet proximity, the kind you would never notice without careful instruments and careful models. If the future merger unfolds, it will likely be a long gravitational dance. The two galaxies will approach, pass through each other, and gradually settle into a combined system. Stars will mostly miss each other, passing by like distant ships in an open sea. The main effects will be on the overall shapes, the orbits, and the distribution of gas. Over very long time, the combined galaxy may become less obviously spiral and more rounded in appearance. But even that outcome depends on details that are still studied and simulated. What matters for this bedtime journey is the feeling of history as calm motion. Galaxies grow by interacting. The Milky Way has been shaped by smaller mergers like Sagittarius, leaving streams like gentle handwriting. And in the deep future, it may be shaped by a larger interaction with Andromeda, adding new layers of memory to the halo and the outskirts. You can let this be soothing rather than dramatic. It is not a story of sudden endings. It is a story of slow blending, slow rearranging, and long continuity. If you notice any tension in your body, you can release it softly. Let your hands rest heavier. Let your shoulders drop a fraction more. Let your breathing keep its slow rhythm. And as you breathe, you can imagine that you are resting inside a galaxy that has all the time it needs. In the next part, we will add one more signature segment, a quiet ribbon of stars as a memory line, and then we will turn inward toward the core, where the Milky Way's heartbeat becomes a different kind of calm, the dense bulge, the central bar, and the steady presence of Sagittarius A star, mostly quiet, holding the center with patient gravity. Tonight, before we turn inward, let us pause in the outskirts one last time, because the outer halo is where the Milky Way's memories are easiest to read, and there is something deeply restful about the idea that history can exist as a pattern without needing to be loud. In the bright disk, everything is layered. Stars crowd the line of sight. Dust veils and reddens. Gas glows and folds. The spiral arms are beautiful, but they are also busy. In the halo, the sky is quieter. The density of stars drops. And in that quiet, faint structures can remain intact for a long time, like footprints preserved in soft snow. Stellar streams are one of those preserved footprints. They are not beams. They are not fences. They are thin, extended trails of stars that once belonged together, now unspooled by gravity. A stream can arc around the Milky Way, as if the galaxy has tied a ribbon around itself. And the ribbon is made of the slowest possible motion, a procession that takes millions of years to shift by a noticeable amount. Signature segment 3. Picture a stellar stream as a memory ribbon. In the dark, a faint curve of stars that keeps the outline of an old orbit. The original system may have been a dwarf galaxy or a tightly bound cluster, and over time, the Milky Way's tides drew it out star by star until the once compact group became a long, delicate arc. Astronomers find these ribbons by mapping huge numbers of stars and looking for coherent stars that share a similar motion through space, and often a similar chemical signature too, like a family recipe carried quietly from one generation to the next. Streams matter because they are sensitive to gravity. Their bends and wraps trace the Milky Way's mass distribution, including the unseen halo, offering clues about the galaxy's shape beyond the bright disk. And beyond the science, a stream is a soothing image. It is proof that the universe records its past in gentle lines. Nothing needs to shout. A galaxy remembers with a curve. Now, with that calm image held softly, we can begin to turn inward, because the Milky Way's history is not only written in its outskirts, it is also gathered toward the center, where the density of stars increases, where orbits become more crowded, and where the galaxy's inner structure takes on a different character. As we approach the inner Milky Way, it helps to let go of the idea of a simple spiral pattern. Spiral arms are most clearly defined in the disk, in regions where gas and star formation highlight them. Closer to the center, the galaxy becomes thicker and brighter. The stellar population changes. Dust becomes more significant along certain lines of sight, and a large central structure begins to dominate the motion, the bar and bulge. The Milky Way is often described as a barred spiral galaxy. The bar is an elongated concentration of stars that stretches across the central region. It is not a rigid bar. It is a collective pattern of orbits, stars moving in ways that together create a stretched shape, and this bar can influence how gas flows inward, guiding it along dust lanes and toward the central regions where density rises. The bulge is the rounded, thickened central concentration of stars surrounding the very inner region. When you imagine the bulge, think of a gentle swelling in the center of the disk, like the soft rise in the middle of a quilt. It is crowded with stars. It is older in many parts, and it holds a great deal of the galaxy's luminous mass. As we drift inward, we are also drifting toward the Milky Way's deepest gravitational focus, the region that hosts Sagittarius A star, the supermassive black hole at the center of our galaxy. It is not a roaring furnace most of the time. It is often described as relatively quiet, especially compared to the active black holes in some other galaxies that blaze with jets and intense radiation. Sagittarius A star is massive, with scientists estimating it at about 4 million times the mass of the Sun, and yet it sits in a calm way influencing the orbits of nearby stars through gravity, acting less like a spotlight and more like a dim lamp behind a curtain, present steady, not demanding. Attention, this is where our story's mood shifts gently from wide-open space to concentrated stillness. The arms were like flowing currents. The halo was like an unseen scaffold. The streams were like memory ribbons. Now the center becomes the heartbeat, not dramatic, but steady. A region where the galaxy's motion tightens into faster loops and more complex inner dynamics. And even here, the galactic year remains in the background, because all the motion from the outer halo to the inner bar belongs to the same long turning. The difference is in the texture. In the outskirts, everything is airy and faint. In the center, everything is dense and bright, yet still part of a slow story when you measure it on the galaxy's timescale. If you feel yourself growing sleepier, you can let the inner galaxy become a comforting image, a distant hearth. Not a fire that burns you, but a warm presence that gives the whole spiral a center to circle around. A home point for orbit. A place that anchors the story. In the next part, we will step more fully into the inner dynamics. The central bar, the bulge, the crowded orbits, and the quiet presence of Sagittarius A star. And we will treat the core as a gentle heartbeat, bringing our journey toward a calm, close, while keeping the tone soft and the transitions smooth. A little farther inward now, and the Milky Way begins to feel less like a wide-open spiral and more like a living city of stars. Not a noisy city, but a dense one. A place where the lanes of orbit are closer together, where starlight overlaps, and where gravity gathers the galaxy into a warmer, thicker center. From our position inside the disk, the galactic center is not something we can simply gaze at with clear eyes, because the view is wrapped in dust. In visible light, the central region can look veiled, as if a soft curtain has been drawn across it. But in other wavelengths, the curtain becomes more transparent, and the shape of the inner galaxy is revealed more clearly. This is one of the quiet themes of astronomy. The universe shows different faces depending on how you look. The Milky Way's center is not hidden, it is simply speaking in a kind of light our eyes do not naturally hear. As we approach the inner structure in imagination, the first thing to meet is the bulge, the central swelling of stars that thickens the galaxy's heart. If the disk is like a wide sheet, then the bulge is the gentle rise at its center, packed with stars. Many of them older, many of them moving on orbits that are not confined to the thin plane of the disk. The bulge is not a single, simple object. It has layers and complexity, and in a barred spiral like the Milky Way, the bulge and the bar are closely related. The bar is an elongated structure of stars stretching across the inner region, and it is best understood not as a rigid rod, but as a pattern of many stars moving on aligned orbits, creating a stretched shape through their collective motion. In calm terms, the bar is like a slow current inside the galaxy, a flow of orbits that reshapes how material moves inward and outward. Gas, in particular, can respond strongly to the bar's gravitational influence. It can be guided along lanes, compressed into denser regions, and directed toward the center, helping to feed star formation in some inner zones and shaping the distribution of matter in the heart of the galaxy. But even here, nothing needs to feel urgent. These flows take time. The bar turns. The disk turns. The entire inner region is a dance of long periods and gentle forces, a choreography that unfolds over millions of years. If you want an image that keeps everything soft, picture the Milky Way's center as a slow whirlpool, not of water but of starlight and gravity. The arms are the broader currents farther out. The bar is a gently stretched swirl near the middle. The bulge is the bright, thickened region where many paths overlap. And within it, all the orbits tighten, not because something is chasing anything, but because the gravitational landscape deepens toward the center. This deepening is natural. In most galaxies, the central regions hold a lot of mass, both in stars and in other forms, and that mass shapes the motion of everything around it. So as you move inward, Orbital periods shorten paths, become more complex, and the density of stars rises. And yet it is still the same galaxy. This is important to keep in mind because the inner Milky Way can sound exotic, but it is simply another part of the same calm structure connected to the spiral arms, supported by the dark matter halo, and shaped by the long history, mergers and growth we have already discussed. The core is not isolated from the rest of the galaxy. It is the place the rest of the galaxy circles. And now, at the center of this inner region, the Milky Way holds something that is often spoken of with dramatic language: a supermassive black hole, Sagittarius A star. Tonight we will treat it gently, because although it is massive, it is also most of the time remarkably quiet. Sagittarius A star sits at the center of our galaxy, and scientists estimate it has a mass of about 4 million suns. That is a number large enough to make the mind wobble, so let it become an image instead. Imagine a deep, steady anchor in the middle of the galaxy, an object whose gravity shapes the orbits of stars in its immediate neighborhood. We know Sagittarius A star is there, not because we see it shining brightly like a star, but because we see stars orbiting an invisible center. Over years and decades, astronomers have tracked the paths of stars close to the galactic center, and those paths curve around a compact region that contains a great deal of mass. These stars move quickly because the gravitational pull is strong. Their orbits, seen over time, become a kind of quiet proof, a choreography that reveals an unseen conductor, and the conductor does not need to speak loudly. Sagittarius A star does not blaze like a quasar. It does not dominate the night sky with jets. It is often described as underfed, not drawing in large amounts of gas at high rates, and so its emissions are relatively faint compared to the brightest active galactic nuclei we see in other galaxies. That quietness fits beautifully into a sleep documentary. It allows us to see a supermassive black hole not as a monster, but as a calm gravitational presence, a dark hearth around which the inner galaxy organizes itself. If you want to carry a soothing metaphor, picture Sagittarius, a star as a dim lamp behind a curtain. You cannot see the lamp directly, but you can see what it does. It shapes the room. It creates a center. It gives nearby objects a reason to move the way they do. Now remember how our journey began with the galactic year, as a slow rhythm. The closer you are to the center, the shorter the orbits become, the tighter the loops, the faster the motion. Yet the galaxy as a whole still turns with patience. The core is the heartbeat region, where dynamics are quicker, but the overall story remains calm when held against the vast timeline of the Milky Way. In the next part, we will settle into the core more fully, bringing together the bar, the bulge, and Sagittarius A star as a gentle inner system. And then we will begin to close the journey by returning to the idea of the galactic year, spiral flow, and the unseen scaffold that holds it all, letting the galaxy feel like a calm clock again, steady and restful. As you rest, let the inner Milky Way become a quiet room at the center of a much larger home. The spiral arms are the soft hallways that curve outward. The halo is the unseen foundation beneath everything, and the core is the place where the galaxy feels most concentrated, not in a sharp way, but in a warm, gathered way, like a gentle knot tied in the middle of a long ribbon. When we speak of the core as the galaxy's heartbeat, we do not mean a dramatic thump. We mean a steady center of influence, a region where gravity is stronger, where stars are closer together, and where the paths of motion become tighter and more intricate. The central bar is an important part of this heartbeat. It is an elongated structure of stars that stretches across the inner Milky Way, and it is not separate from the disk. It is the disk shaped into a different pattern near the center. Stars in the bar follow orbits that collectively create a stretched form. If you want a sleep-friendly image, think of a slow river that narrows and quickens as it approaches a bend, creating a long, smooth curve of flow. The bar is like that bend in the galaxy's motion, a place where the pattern of orbit changes shape. Because the bar reshapes gravity in the inner region, it can guide the movement of gas. Gas can be nudged along lanes, compressed and directed inward. Over a long time, this can influence where new stars form in the inner galaxy and how material is redistributed. The details are complex, and scientists continue to refine the picture. But the calm truth remains. The bar helps organize the inner Milky Way, like a slow, stirring motion that keeps the center structured. Around and within this bar lies the bulge, the thickened central concentration of stars. The bulge is crowded compared with the disk. It holds stars that can be older on average, and their motions can be more varied, not as neatly confined to the thin plane. The bulge gives the Milky Way a three-dimensional heart, a region that rises above and below the disk like a soft dome. And then, deeper still at the very center, there is Sagittarius A star. Tonight it is helpful to hold Sagittarius A star, not as a dramatic object, but as a quiet point of gravity. Scientists estimate it at around 4 million solar masses, and it is surrounded by stars, whose orbits are the most intimate demonstration we have of its presence. Those stars loop around an unseen center, and their paths, traced over years, show us that a great deal of mass is concentrated into a very small region. This is one of the gentle wonders of astronomy. We can learn about something invisible by watching what moves around it. We can learn about the heart by listening to the rhythm of the body. In the Milky Way's center, that rhythm is literal in a sense. Stars close to Sagittarius. A star move on short, swift orbits, compared to the slow galactic year of our Sunday. They are like inner hands on a clock, ticking faster near the center, while the outer hand turns slowly around the whole face. This image is calming, because it lets you see the galaxy as a layered clockwork. The outskirts move with deep patience. The inner region moves more quickly. Yet everything belongs to the same calm structure, and nothing needs to hurry in the way that human minds sometimes hurry. If you imagine the galaxy from above again, the spiral arms are still there, flowing out from the inner region. The bar sits like a gentle bridge in the center. The bulge swells around it, and around everything the dark matter halo provides, the deep gravitational background that keeps the whole system bound. This is the Milky Way as a complete organism, a spiral surface, a three-dimensional heart, an unseen skeleton, and a long memory written in streams. Now, if you are still awake, you might notice how restful it is that these pieces fit together without conflict. Spiral arms can be patterns that move through material. Dark matter can be a framework that shapes motion without shining. Mergers can add stars and leave streams without destroying the whole. The bar and bulge can reshape the inner region while the outer disk continues its long orbit. The Milky Way is not fragile. It is resilient in the calm way that systems become resilient when they have had billions of years to settle. And here at bedtime, we can let that resilience become a kind of comfort. The galaxy has carried countless stars, countless worlds, and it carries us too without effort, without needing permission, holding us inside its motion, like a cradle. If you would like one more soft relaxation cue, let your breathing be easy and unforced. Let your eyelids feel heavier. Let the muscles in your face soften as if your expression is being smoothed by warm air. And as you do, imagine the Milky Way's core as a distant hearth, steady and quiet, giving the galaxy a center to circle. We are close now to the end of this journey arc. In the next part, we will gently gather the whole story into one calm closing, returning to the galactic year as the slow rhythm, the arms as the flow, dark matter as the quiet scaffold merges, as memory and the core as the heartbeat. And you will let it all settle into a final soothing image you can carry into sleep. Tonight, as we begin to settle, let the Milky Way return to its simplest comfort, a slow turning home, moving with a patience so deep that it can soften even a busy mind. At the beginning of our journey, we used the galactic year as a calm clock. One full orbit of our sun around the center of the Milky Way is a long, quiet period, far beyond human schedules, far beyond any single lifetime, and that is why it can be soothing. It reminds you that there are rhythms in the universe that do not demand anything from you. They simply unfold. Inside that slow rhythm, the spiral arms become the gentle currents, not rigid rails, but drifting patterns, places where gas gathers, where new stars light up for a while and then drift onward. The arms are like a soft melody laid over the steady beat of the galactic year. They wind and flow, and even when they change slowly, the way weather changes over a landscape. We let that image become even softer when we spoke about the disk warp, the subtle bending at the outskirts of the Milky Way, traced through maps of hydrogen gas and careful observation. The galaxy is not a flat diagram. It is more like fabric, capable of a gentle ripple, a quiet lift at the edges, a reminder that even enormous structures can be flexible. Then we stepped into the unseen framework dark matter, the quiet scaffold that helps explain why galaxies rotate the way they do, and why they remain bound. Whatever dark matter turns out to be, the evidence suggests it behaves like mass-shaping motion through gravity. And in a bedtime story that makes it feel like the most peaceful kind of support present, without shining steady, without speaking, holding the luminous spiral in a broader embrace. From there, we moved into memory, the long history of collisions and mergers, and we softened the word collision until it became what it often is, on cosmic scales, a slow dance. Smaller companions like the Sagittarius dwarf galaxy have looped around the Milky Way, and over time tides have drawn them out into stellar streams, faint ribbons of stars that arc through the halo. Those ribbons are not scars. They are signatures, the galaxy writing its history in curves. And we widened our view toward Andromeda, a larger neighbor whose future interaction with the Milky Way is a story measured in billions of years. Even if that merging day comes, it will come gently by human standards, with stars mostly passing by with gravity, reshaping the overall structure over long time. A galaxy does not rush. It rearranges itself, the way a slow tide rearranges a shoreline. Finally, we drifted inward to the core, where the Milky Way's heartbeat lives. The central bar, the thick bulge, the crowded inner orbits, and at the very center, Sagittarius A star, a supermassive black hole that is mostly quiet. Scientists estimate it at about 4 million solar masses, and we know it is there because nearby stars orbit an invisible center, their paths forming a calm proof. It does not need to blaze to be real. Its gravity is enough to shape the inner galaxy the way a silent anchor shapes the motion of a boat. If you hold all of this together, the Milky Way becomes a complete soothing system. A slow clock, a flowing pattern, an unseen scaffold, a long memory, a steady heartbeat. And now you can let your mind do what the galaxy does. You can let it drift without forcing it. Thoughts can be like stars, each on its own orbit, each passing through denser regions and quieter regions, and none of them needing to stay forever. A thought can arrive, glow softly for a moment, and then move on. If you are still awake, let your breathing remain slow. Let the space behind your eyes feel wider. Let your shoulders sink a little more into rest. You have got nothing to do but rest. And in that resting, you are not separate from the story we told. You are inside it. You are part of a galaxy that has carried light for billions of years, part of a universe that holds structure without strain. For a final image, imagine the Milky Way from far above, a faint spiral in the dark. The arms are soft like brushstrokes. The disk is slightly bent at the edges, like silk. Around it all is the unseen halo, a deep, gentle architecture of gravity. Across the outskirts, faint streams curve like memory ribbons. And at the center, the bulge and bar gather, and Sagittarius A star sits quietly, the still point around which the inner heartbeat turns. Everything is moving, and yet nothing is demanding your attention. The galaxy turns, the arms flow, the halo holds, the streams remember, the core steadies. If sleep is near, let it come the same way the galactic year comes slowly, without effort, without needing to be pushed. Let your thoughts thin out like stars in the halo. Let the night become wider, and let your rest be gentle, one calm orbit at a time.